We're going to look at a couple of questions now dealing with identification of dilations. What we're going to do is we're going to identify dilations of possibly 2D or 3-dimensional objects, and we're going to use similarity to determine if something is a dilation. In this triangle, in this question, we have triangle ABC as shown. If the triangle is dilated by a scale factor of 2, how much bigger is the area of the new triangle? Remember that if something gets dilated by a scale factor of 2, that means that all the dimensions, all the sides, are going to increase in size by a factor of 2. So when A was 7, it's no longer 7. A is now going to be 14. B is no longer 13. It's going to be 26. And C is no longer 8. It's going to be 16. So all of our side lengths have doubled in size. So the old area is equal to our old base times our old height divided by 2. That's the area of any triangle, base times height divided by 2. Plus, my area of my new triangle, well, I do know my base. I don't necessarily know my height based on the shape of this triangle. But I know that my base and my height, all my dimensions are going to be doubled. So my new area is going to be 2 base times twice the height of the original divided by 2, which is going to be, if we multiply the numbers in our top together, we're going to get 4 times BH divided by 2, which is equal to 4 times our original base times height divided by 2. So this, right here, this is our old area. And our new area is going to be 4 times larger. So the answer to this question is C. Whenever we have a triangle or any shape really that's multiplied or that's dilated by a certain scale factor, the area, the new area, is always going to be my scale factor, which I'm going to call S squared. So the new area is going to be S squared times whatever the old area was. Now, determine whether VWXY is a dilation of RSTU by comparing side lengths. Now, once again, in a dilation, if we have an enlargement that is a dilation, then all of the side length ratios are going to be equal. So we have to compare corresponding sides. So for side RS, the corresponding side in the smaller quadrilateral is going to be VW. For this to be a dilation, that has to be equal to RU divided by VY, and it has to be equal to TU divided by XY, and it has to be equal to ST divided by WX. Okay, so if this is a dilation, all of these have to be equal. If, true if a dilation. Okay, so we have to work out all of those ratios. So RS, I'm going to do it down here. RS is equal to 15. And WV is equal, or VW is equal to 3. RU is equal to 13. And VY is equal to 3.2. TU is equal to 10. And xy is equal to 2. And finally, wx is 13, and st is equal to 3.2. Okay, so RS over VW is 15 divided by 3. 15 divided by 3 is equal to 5. Now, what is 13 divided by 3.2? Probably not so obvious. So 13 divided by 3.2, I do that out of my calculator, and I get an answer of 4.0625. Well, they are not equal. So what that tells me is that I don't have equal ratios between corresponding side lengths in these two quadrilaterals. So what that tells me then is, because the side length ratios are not equal, I don't even have to calculate the last two because I found one that doesn't work, right? So because the side length ratios are not equal, RSTU and VWXY are not similar. So VWXY is not a dilation of RSTU. So once I find that one pair of side ratios is not equal to each other, I can stop right there. I know that this is definitely not going to be a dilation. So to summarize, a transformation is a change to an object. It can be a dilation in our case. We could also see translations, reflections, rotations, or some combination of all of them. When a transformation is performed, the new object is called the image. For us, a dilation is either an enlargement or a reduction by an object by some scale factor. The scale factor must be applied to all dimensions. And dilations have the same corresponding angles and corresponding side length ratios. And again, in the second example, we saw that the side length ratios were not equal, so we did not have a dilation.